Okay, so we will talk about the exponential growth and the decay model here. And so the mathematical model for exponential growth or decay is given by ft equal to a0 ekt, and it will be a growth model, a decay model. It all depends on k. If it's positive, it will be one more, so it continues to grow. If it's negative, it will be one lower, so it will be decay model. Okay, and in biology, we also introduced another model. It's called logistic model. So the logistic model is given by ft equal to c over 1 plus ae to the negative bt. Okay, so or a equal to this, where a, b, c are constants. Okay, so this is logistic model, and in biology you have special meanings of these things, and if you want, you can find a biology textbook and find the meanings here. So we wanted to see the mathematically. So when t goes to infinity, what will be ft approaches? Okay, so it's c over 1 plus a e to the negative bt. Negative exponent means what? 1 over. So it's a over e to the bt. Okay, a over e to the bt. And when t goes to infinity, so this part go to infinity. Yeah, and any number over infinity means over a very, very big number. This part goes to what? 0. So this one will be c goes divided by 1 is equal to what? C. So this is why the picture of logistic model. So you start with something, you increase very quickly, and then it will be flat. Okay, a logistic model can also be used to model like okay. So for the moment, the cases, how many more cases of COVID? Okay, so after the vaccine, after the treatment, and all the people who get the COVID will come to a flat. Okay, we hope so. And and as time goes, it should reach a constant, and ft goes to c. Okay, so this is the best property of the logistic model. And for the growth model, okay, so e to the k, if it's positive, what happened? It will be go like this. Yeah, decay model, what happens? It will be go like this. Okay, approach 0. This is growth. This is what? Decay. Okay. Okay, so we wanted to look at two examples. The paint discovered from a long time ago contained 20% of the carbon-14. So we wanted to use exponential decay model for carbon-14 to estimate the age of this paint. Okay, so we know that A equal to a0 e to the negative 0.0000121 t. Okay, so now this is original. Your original carbon-14 is what? A0. This is your original. Is original carbon-14. And A is your current carbon-14. Yeah. So what will be A equal to? We know that is what? 20%. 20% of the what? Original. Okay, of means what? Multiplication is 0.2 A0 here. Are you with me? So A equal to what? 0.2 A0. So we substitute here. 0.2 A0, A0 e to the what? Negative 0.0000121 t. What happens here? A0 cancelled, yeah. And how could you solve for this one? As we talked about it before, this is e, yeah, equal to a number. You want to change to logarithm form. So what do we have? Negative 0.0000121t. It will be what? E is still the base. It will be ln 0.2. So what will be t? Is ln 0.2 negative 0.0000121. Yeah, 0.0000121. So what do you get for when you use your calculator? Almost what? 13301. So it is 13,000 years and 13,301 years almost. Okay, wow, long time, yeah. So the half-life of a certain substance is 25 years. How long will it take for a sample to decay to 95% with a certain amount? Okay, so we want, this is what? A decay, yeah? So half-life. What means half-life? Okay, so we wanted to use the model A0EKT again. What means half-life? Half-life is 25, yeah? Okay, half-life is 25. Half-life means your A equal to what? Half of your original amount is equal to a half of A0 when what? When t equal to what? 25. Are you with me? When t equal to 25. After 25 years, your A will be a half your original amount. Clear? So what do we have here? It's a half of A0 e to the what? K times what? 25. So A0 cancel. What do we have here? E k 25 equal to what? 1/2. K times 25 equal to what? Ln a half. And what will be k? Ln to the half over 25. Yeah? And then what will be the next step? We know that A, which will be what? A0, your k is what? Ln a half over 25 times t. I do not have a calculator with me for the moment, so you can use a calculator to find it what exactly. So what do we want? We wanted to find the years, yeah? So we wanted 95%. A, what will be A now? It's 0.95 of A0. Are you with me? So it's 0.95 of A0, e to, the number you should use your calculator to find. And then A0 cancel, use the same thing. What will you get? Your t, I do know your t. Okay, because I have the answer key here, is 1.9 years. Okay, so you should choose how many decimal places depending on the question. For this question, you wanted to use 1 decimal, so then you choose 1.9. Okay, so that's for this section.